Okay, so the ray diagram or the rules for ray diagrams would be the first rule says that if this is the principal axis and this is the lens, any light ray that is parallel to the principal axis, meaning that it's coming straight towards the lens, after crossing the lens, it will always pass through the focal point, no matter what happens. Okay, so rule number two is actually vice versa of this principal axis, lens. This rule says that if any light ray is already or has already passed through the focal point before touching the lens, after crossing the lens, this will become straight parallel to the principal axis. Do we understand this? So they are basically mirror images, or you can say opposite to each other. These rules are vice versa of one another, right? So this is focal point and this is also focal point. Okay. So the third rule and final rule is the simplest one. It says that any light ray passing from the optical center from any angle will not bend and will pass straight through. And it doesn't matter where it's coming from. So it could be coming from this angle. We don't care. It is going to pass straight through. Okay. Yeah. Yeah. It will not bend. The way these have bent, that light ray will not bend. And generally, I start my question with rule number three. It makes it easy to visualize the rest of the parts. And this line will always be a part of the ray diagram. It's impossible to draw a ray diagram without this. So, of course, it's possible in some cases, but when I say impossible, that would mean that in majority cases, or rather in approximately 99% of the cases, if you start your question with this rule number three, right, the rest of the question becomes easy to visualize. If you start with rule number one or two, in some cases, if the diagram is very simple, it's very basic, you can solve it easily. But in some cases, I've seen that rule number one and two don't even fit into the diagram. So you have to start with rule number three to actually understand where the lens might be. You see, I will share a trick question with you after learning how to draw the ray diagram. Okay, so just a moment. All right, so let's try to draw the ray diagram for a converging lens. The same thing that we did before. So let's say this is my principal axis and this is my lens, right? What I would advise you is if you have a ruler, a pencil, and a copy with you right now, it would be a great exercise right now, and you can verify whether you get the answers that way or not. So can you please grab a notebook, ruler, and pencil? Okay. Is for every other diagram that we're going to draw from now onwards, I will fix a few things so that we don't have to discuss them again and again, right? For the sake of diagram only. So how do we represent the object in the diagram is by representing an arrow, okay? So the height of the object for all your diagrams, I'm fixing that to 2 centimeters. So what you're going to do is you're going to draw the 2 centimeter heighted object by placing the ruler like this. Where I'm going to tell you that's another thing, okay? So you place your ruler like this and draw the object and measure it exactly 2 centimeters, all right? Okay, this is, I'm fixing this. The other thing that I'm fixing is the focal length, which is going to be 3 centimeters. So use the ruler, place it like this, and measure 3 centimeters points on both sides and label them as F on both sides. And why do we have focal points on both sides? Because we have curved faces on both sides. So even if the light ray is coming from this point or it's coming from this point, it will converge or it will focus up at one point. So that's why we have focal point on both sides. Okay. All right. Once you're done, let me know. Okay. 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 Okay, good. So first, draw a straight line through the optical center and the top of the object by rule number 3, that any light ray passing from the optical center will pass straight through without bending, right? So you will place your ruler like this and draw that line. Can you do that? Okay. Okay. So now you'll understand why do I discuss or why do I prefer rule number 3 first or starting point as compared to the others. Okay, so the next stage would be to draw a straight line towards the lens, as straight as possible to the principal axis. And where do you think it should pass from? Where should it go after crossing the lens? Yeah, so So what you're going to do that this is your first coordinate and this is your second coordinate for a straight line. So what you're going to do is use your ruler like this and draw a straight line as far as it goes, and you will observe that they intersect at one point if you have a long enough page. Do you see that? Okay, so eventually it will intersect with that other line, right? So wherever these two lines intersect, we will realize that our image will be formed at that place or at that position, like this, right? And of course, all of these are straight lines. I'm just drawing it freehand, so that's why I'm unable to do that. So do we understand up to this point? Okay. Yeah. So, and please be advised that the image is actually inverted. If you realize, the arrow over here is at the top, but at this place the arrow is at the bottom because we were drawing the image for the arrow. So wherever the lines intersect are actually the place of the arrow. So the rest of the line actually is going to be drawn besides or towards the lens. Do we understand this point? Okay. Now do one more thing for me. Reset or redraw this principal axis and focal point, but now draw one more extra point, that is 2f. If if the focal length is 3 centimeters, the 2f point will be at 6 centimeters, right? So f and then 2f, and what I would want you to do is draw the object of 2 centimeters exactly at the 2f location, and then try to draw the diagram and see where is the object go, or where the image will be placed, or where the image is going to go. What? I couldn't get your question. Can you repeat the question, please? Yeah. Object is draw the object of 2 centimeter height at the 2f point. Yeah. Okay. What I would advise you is you can keep your notebook not like this, but like this. So yeah. So if you do that, then it will be easier. Yeah, but now the object is at 2f. If over here you realize the object was closer to f, no? Now it's a bit further than f and closer to 2f, or exactly on 2f. It's a different diagram. But the rules will be the same. Try to draw that, and I will confirm whether it's right or not. So it will be somewhat like this, and then a straight line towards the lens, passing from the focal point, somewhat like this. I will find my point of intersection this place, which is going to be at 2f. This is my image. Your diagram should be exactly at 2f. You will find the point of intersection exactly or a bit different, but it will be very, very close to 2f. Is that not the case? Exactly. We will get to the ideas and trick points later, but first confirm the diagram where that is. Yeah. Okay. So 2f has no other significance other than this idea that if you place the object at 2f, it will generate the image at 2f. And the trick behind this is that if you bring this object closer to the lens, your image goes further away. So they are in sync somehow. So if you go on the upper diagram, when you were closer to f, your diagram moved away from 2f, and it was so far away that it actually got out of the notebook. Do you remember that? Right? So similarly, if I take this even further or any further away from 2f in this direction, your image is going to move in this direction, closer to f. So this is a trick point, or you can say this is a reference point. The 2f line is a reference point for us. If you go closer to the lens, your image goes away. If you move away from the lens, your image also comes close to the lens. Okay? All right. So there is another idea behind this. Try to observe that and try to draw that over on your notebook as well. You see, we did another rule that said that what if the line was already passing from the focal point, it will become straight after crossing the lens. Is that so? Right? So try to observe that since there are infinite light rays originating from the object, but we only draw two, let's try to draw another light ray that actually passes from the focal point like this. Do you understand that? Right? So it passes from the focal point before crossing the lens, and you will realize that if you draw it properly with the ruler, when it becomes straight after passing through the focal point, this way it will intersect at this point where it previously produced the image. Try that and see whether it's true or not. Hmm. All right. All right. So this is how we draw the ray diagrams. Let's consider a few special cases for the ray diagrams that are actually tricky questions in the examination. See, I would like you to reproduce this image, draw the principal axis and the lens place, and try to replace the object at the F point. Try to replace it at the F with the same measurements and try to draw the diagram this time by following the rules and see what happens. So when they pass through the focal point and this line passes straight through, we realize that they are parallel to each other. We find this case in real life when, for example, if I consider your eyes as the lens right now, when you start bringing your hand, for example, closer to your eyes, right? So there comes a time when the image is very sharp and then it starts to get blurred. The very first time you see that the image is blurred now is actually that point where the focal point of the lens of your eyes exist. So in that case, this is what's actually happening at the back end. When you bring your hand closer to your eyes and the very first time you lose focus, this is what's actually happening at that point, right? So since the light rays don't converge at one point, the focused or a sharp image is not formed inside the eyes. So that is how we basically estimate the focal length or the focal point of the eyes of the human being. And this is just an estimate, not an accurate, of course, calculation. But do we understand where we find this in real life? Okay. All right. Okay. So how about this one? Draw this setup again, and this time we're going to do something even different than this. So this is your focal point. This time place the image at this place between the focal point and the optical center. Try to do this one. If they're diverging on the other side of the lens, can we assume that they must be converging at some point if we overextend the lines? You see, if I carry the lines forward and they pass through the focal point and then they through the optical center, since they're diverging at this side, it's possible that they actually are converging at some other. So if I extend these lines backwards, again placing my ruler with dotted lines, will I see a point of intersection at this place? So this is my object and this is my image. Yeah, yeah. So where are our eyes right now? So our eyes are at this place and we're trying to observe the image because they couldn't intersect at this place and they're intersected at some other place. So to view this image, I should be on the other side of the lens. Okay. Now the real life example of this is basically magnifying glass. And this question has a very high occurrence in examination because students generally forget about this case because what they assume is that every single time they're going to encounter a convex lens that is converging, they're always going to find this case of the image. But there is a special case. The first one is this one when the image is not formed at all. Or we assume that the image will be formed at infinity because we don't know where that focal point will be or where the point of intersection will be. So we just say that the image may be forming at an infinite distance. We don't know where it is. And this is the special case. Again, over here is the first time that the light rays are diverging rather than converging. So students generally forget about this. And this is a magnifying glass. That is how you use it. So basically, when you're trying to view an image through the magnifying glass, if this is the magnifying glass and these are your eyes, what you have done is place a piece of paper or the object that you're trying to magnify beyond or between the focal length and the optical center of the lens. So you see its image being extended at somewhere other place which is slightly magnified at that point, like this. Do you see that? Right? So that is how we are using the magnifying glass. Okay? And this is also a case that is a part of your syllabus, that is a part of your course. Okay? So are we familiar with this? Yeah? This is a convex. We haven't started diverging lens. These are all concave. Yeah, yeah. Now, these are the only confusing points about the convex lens. We are going to draw the ray diagram of diverging lens. Okay, so what I'm going to do, just a moment. What I'm about to do is, again, redraw or reset the principal axis and the lens. So be advised that this is the lens that we're talking about now. Okay, the lens that actually diverges the light rays. That looks like this. Okay, let's say this is the focal point, and this is where the object is being placed. You see, the light rays actually, the first light ray that I'm going to draw will be the same. That is the point number 3. or rule number 3, that any light ray passing from the optical center will pass straight through. I'm deliberately extending it over here so that if any point of intersection may light outside the diagram, I don't have to draw that line again. So as a precautionary measure, I'm going to draw a longer line to overcome this effect. Right? Okay. The second light ray that we're going to observe at this point will be exactly the same way, straight line moving towards the lens, but this time, instead of converging, it will be diverging. Now, we observe that this is the focal point at this point, so the light ray is actually going to diverge, but keeping in mind or looking at what will be the reference point of this light ray. So it's diverging, but keeping in view with the focal point. Do we understand this idea? Right? So after you draw the straight line, you're going to place your ruler like this, right? And you have 2 points. The first is the focal point, and the second one is this line. The first one is this one. So you draw a straight line passing this way over here, okay? And you will find the point of intersection at this location. Do you see there? We find the point of intersection. This is our image and this is our object. This one, right? So please try this diagram.